Okay, so let's go over the answers to bell work number 2, factoring trinomials. And if you look at problem number 1, luckily the leading coefficient on the first few problems is 1. So that makes it a little more convenient for factoring. So let's go ahead and put our parentheses out here. And since I have 1x squared, then I know that the leading terms in each factor will be x and x, because x times x is x squared, right? So that would check when we FOIL it. Now I have to look at this sign here, and since this is negative, that tells me that the signs of the factors have to be different. One has to be positive and one has to be negative. Because when you FOIL and you multiply the last terms together, right, you would multiply this item times this item, and in order to get a negative 30, those signs would have to be different. Okay. Now let's see. We've taken care of the signs. Now let's look at the 30. What are the factors of 30 that will somehow combine to give me a 7? Well, the factors of 30 could be 1 and 30, but I'm not going to get a 7 by adding or subtracting those integers, right? So that's not going to work. So scratch that one out. 2 and 15, 2 times 15 is 30. But again, there's no way I can add or subtract these to get positive 7, so those two are out. Let's look at 3 times 10, right? 3 times 10. And I notice that I can get a 7, right? And it appears to me that the signs are different because of this being negative, and this positive tells me that the biggest number takes the positive. Since 10 is bigger, it's going to go into the positive position, which means the 3 would have to go here. So let's check that. Let's FOIL this out to see if this works. I'll change colors here. So I've got x times x, that's the first terms. Remember, we're doing FOIL, first terms. X times x is x squared, so that checks. Then I have to do the outside terms, right? I have to do the outside. So negative 3 times x is negative 3x. But when I add the inside terms, I end up adding 10x, right? So negative 3x plus 10x is positive 7x. Remember, watch those signs. And then finally, we will multiply the last items together, and positive 10 times negative 3 does give me a negative 30. So it appears to me that the answer is x plus 10 times x minus 3. Okay, problem number 2. On problem number 2, luckily we have a 1 again, and the leading coefficient there. So I'm going to put my parentheses out here. And n times n is n squared, so that takes care of that. And now I'm looking at this negative here, right? That's a negative 6. That tells me the signs have to be different. Knowing that little trick alone might help me rule out one of the incorrect answers, because here the signs are the same, so I know it's not that one. And that narrows it down to 3 options at least. And let's see, what are the factors of 6 that I can use to get a 5? Well, this one can be tricky because 1 times 6 is 6, and I could get a 5, right? Because there's a difference of 5. But also 2 times 3 is 6. And I can add those together to get a 5. So now I have to sort of play a game here. What would work? Well, let's see. If I put a 6 here and a 1 here, that's going to give me negative 6n plus 1n. Well, that's negative 5n, and I need a positive 5n. So that's not going to work. So what do we do in this case? Well, let's try something else. Let's reverse those. Let's reverse those. Let me put the positive here and the negative here. I should have done that in the first place, because we know that since this first sign is positive, then the biggest number takes the positive, right? And since 6 is bigger than 5, I should have put that there. Now let's check the outside and the inside. Well, on the outside, I now have positive 6n, And then when I subtract on the inside, that's minus 1n, and 6n minus 1n is 5n. So it looks to me like the answer has to be n minus 1 times n plus 6. Okay, let's take a look at problem number 3. Problem number 3, again, factoring. And I'm going to put an R here and an R here. Now this problem is a little different because I have a positive here. And that means the signs are going to be the same. And if you look here, this tells you that the signs are both negative. Okay, signs are the same, both negative. So let's see. Okay, continuing right along, I'm looking at this 60 here. And I'm asking, okay, what are the factors of 60 that was somehow combined to give me the 16 here? Well, the factors of 60 are, let's see, 1 times 60. And then I have 2 times 30. Notice that none of these will give me a 16, right? I can't add or subtract these to get 16. I've got 3 and 20. 3 times 20 is 60, but I still can't get that 16. 4 and 15 multiplied together, those will give me 60, but I still can't get a 16 out of that. I know that 5 times 12 is 60. Not very helpful with the 16. And I know I have, let's see, 6 times 10. It looks like we finally found the one we need, right? Because I can get a 16 using 10 and 16. So let me do 10 here. Since the signs are the same, it really doesn't matter if I put the 10 here or the first position, but we'll just go ahead and get this done. So it looks to me like the answer is r minus 6 times r minus 10, and that will be here. And let's check this. I want to do this FOIL thing. So r times r is r squared. That's good. That's the original. That's the first term. Then I have negative 10r minus 6r. That's negative 16r, which takes care of the second term. And then finally, a negative 6 times a negative 10 is positive 60. So that did check. Question number 4. On question number 4, just for the sake of time, I'm going to go ahead and show you the answer. The answer is x plus 20 times x minus 3. And if we check it, we should be able to verify that. So let's do that. X times x, first terms, is x squared. Then on the outside, I would have negative 3x plus 20x. That's positive 17x. And then positive 20 times negative 3 is negative 60. So that does check. And finally, the last problem, problem number 5. This one is sort of, you know, when you have a party and you invite people over and somebody shows up uninvited and sort of ruins the mood, right? Well, that's what's happening with number 5, because I no longer have a 1 as my quadratic coefficient. I have a 3, so I can't do x and x, right? But luckily 3 is prime, which means the only factors are 3 and 1. So I'm going to put a 3x here and an x here. And now I would just factor normally, right? I would have to look at the factors of 120. That would give me a 9 if I FOILed this, right? Taking into consideration the 3. So that one would factor a little differently. But luckily, the problem is not asking us to factor. The problem is just asking us to find the greatest common factor. In other words, is there an integer or a variable that goes into all of these terms? Well, I can't take out an x from all 3 terms because the third term is constant. There is no x. But I could take a 3 out, right? Because 3 goes into 3 one time, 3 goes into 9 3 times, and 3 goes into 120 40 times. In fact, if I wanted to factor a 3 out, I could do this, and that would leave me x squared minus 3x minus 40. So the directions just said, what is the GCF of the trinomial? And that would be 3. Now, just for a little extra, would it be possible to factor this further? We factored it by taking the 3 out, but is it possible to factor that second part? In other words, can I factor x squared minus 3x minus 40? Actually, I could, because x and x will give me x squared. And I know that since this is negative, the signs are going to be different. And I know that 8 times 5 is 40, and I know that 8 and 5 have a difference of 3. And I believe this would do it right here. So if you were told to completely factor 3x squared minus 9x minus 120, you'd have to bring your 3 out here. That was the first thing we did, was we factored the 3 out. But this would actually be factored form. So if I change the problem on a test or on your homework, and if I say, hey, completely factor this, then this would be your answer. If it just says what's the greatest common factor, then you would have this as your answer. So why did I do all of this? It's to teach you to make sure that you always read the question. Always answer the question. Never assume that you are answering it correctly. Make sure you read to verify that.